Oh, yeah, okay.
Okay, for homework 2D, Carly Kraft and myself, we are presenting the anatomy and physiology of the ear, and specifically on tonotopic organization. So we built a model. As you could see, it shows the outer, middle, and inner ear mechanism. On the outside, we have the prominent features with some labeled landmarks. It cuts off below at the lobe. And then we have going through the external auditory meatus into the tympanic membrane. We have the ossicular chain of the malleus, incus, and stapes, as well as the semicircular canals with the inner ear featuring the cochlea, which goes into the auditory nerve, and then up to the brain, which sends electrical signals to the temporal lobe.
So specifically, we're going to talk about what goes on in the cochlea. So tonotopic organization happens in the cochlea, which is labeled number 7 on our diagram. And tonotopic organization is basically happens because of the shape of the cochlea. Because of the spiral shape of the cochlea, the base of the apex is wider, which has the higher frequencies, and the apex of the cochlea is thinner, and that's where all the lower frequencies basically hit their best place. So yeah, the lower frequencies travel all the way up to the apex, where it's wider, and the higher frequencies travel to the base of the cochlea, where it is thinner. Each frequency has a space and location on the basilar membrane that it responds to best, and that's called its best frequency. We have a better example of this in the next slide.
So we want to just focus on the systematic mapping of sound frequency. And this next slide will explain more in further detail.
Yep, so this is basically a very basic diagram of the cochlea, and the basilar membrane is shown as well. So you see the apex is labeled and the base is labeled. The base, you see the higher frequencies, and as you move towards the apex, you see the lower frequencies. So for an example, if we hear a sound that is 3,000 hertz, the sound wave will travel all the way to 3,000. And at that space where it's labeled 3,000, we have maximum displacement. So that is technically considered 3,000 hertz is the best place for that frequency, that wave.
Yep. And lastly, we have a very brief YouTube video that can be watched on how the ear works. This model gave a really great overview of all the systems and the mechanisms, but we are missing a few things, like if you were to cut the cochlea, you would see the different chambers of the scala media, scala tympani, and scala vestibuli. So this video kind of goes into more depth to explain some of those features. And that is our anatomy and physiology for the ear and tonotopic organization. Let's see.